A warm wishes to all the dignitaries who is going to hear this. And now I am going to present my major topic on prediction of wind power generation by using regression method. In this we have chosen our domain as a machine learning and we have developed using Anaconda. And we are two people from a group who is going. Now I am Svetanjali who is going to present our topic and going to explain about our report. Abstract of our topic is it will be predicting the all wind is going to give us, and it will be associated with all the techniques what we have used. Wind power production plays a key role in our dealing with the challenge of balancing supply and demand in any electrical system, gives the uncertainty associated with the wind farm power output. In recent years, some countries have set renewable to meet future energy needs with the primary goal of reducing emission and promoting sustainable growth. Knowing the amount of energy that will be providing is a key. Is minimizing the operation cost of the wind farm and save operation of power grid. System proposes a production model to solve a real life problem in renewable energy sector by accurately estimating the amount of wind energy production per hour in next 24 hours by applying machine learning techniques using historical wind power generation data, weather forecasting report, wind power prediction and require for the turbine control, load tracking, pre-load sharing, power system management and energy trading. Data mining is a commonly used technique for process enormous data in all domains. Researcher is to build a machine learning model capable of predicting power generation. Different regression algorithms are compared and decision tree is the best model used for predicting the outcome. And our aim of the project is to every grid operation has the same issue with the successful integration to meet current demand due to intermittent nature and limited control over the conditions. The project domain, as I said, we have chosen the machine learning. Coming to the scope of the project, wind energy is available without any cost and it does not emit any greenhouse gases. This makes it a great source of energy production for any development state. This field of wind energy has tremendous scope for innovation, translating to the real world application and tremendous economic opportunity. It existing system they have did using wind power prediction interval, which is known as WPPI, is the most common technique of for wind power uncertainty. So in system here we'll be predicting the power generation in power plant, and here important techniques for recognizing power generation to accomplish the load. Here are the feasibility study, economic study, technical. As I said, we have as hardware we need Intel i3 and hard disk of 10 GB, RAM of 4 GB. When it comes to software, Windows 10, and we have used the tools Anaconda with Jupyter Notebook. See, Anaconda standard use we have used this ISO IEC to 27001 and Jupyter of ISO same. Here is the general architecture of the of our topic. So in general architecture, we are showing that website, dataset processing, visualization, accuracy, model, and output. So it is in data flow diagram, we'll be just giving the output. So it will be pre-processing and uses the all the regression method what we have said, and it will be evaluating and it will be predicting the output. Coming to this, it is an use case diagram here. It just show the layout of the program what we have did in step by step. In first step we have collected the data, classification method, training data, test data, building model, and at last we'll be predicting output. This is the class diagram which is shown as a block in rectangle shape, and it will be connecting through the arrow, one arrow mark. Here it shows the output, and you can go through this. This is a sequence diagram which is easy to comparing to all these diagrams. It is a easy one which we can draw, or we can give by showing it. We can give the structure of our program, our project, and easy to explain. It is a collaboration diagram. You can go through this. Here it show object interact to achieve a particular outcome. And this is an activity diagram. As I said that we have used in three algorithms: linear regression, decision tree, SVR, and elastic net. Pseudocode, as it is simple and will be done denoting: load the data set, preprocess the data, split the data into training and testing set, choose algorithm, train regression, train model, evaluate the accuracy by MAE, MSE, R square. At last, coming to the eighth step, deploy the model for wind power prediction. In this, we'll be collecting the data, pre-process the new data, use the trained model to predict the wind power output for the new data. Coming to the module, uh, here in module 1, data process, input is data, output is removing the noise data. In module 2, the input is data, output is visualized data. And in module 3, as I explained, we are going to use algorithm. So it is important to perform in multiple machine learning algorithm. It will discard to create a test harmless for to compare multiple different machine learning algorithms in Python with scikit-learn. It can use test harmless as template on your own machine learning problem. See, here is the output of accuracy what we have used all the regression methods and output of the regression. When we use when we used a linear regression, we got 91%. When we use decision tree, we are getting the perfect accurate value number 99%. When it comes to SVR, we are only getting least amount of the person, so we are not going to choose that. When it coming to fourth method, we have used elastic net percent. It is of 91%. Coming to the module 4, we have used deployment. So here it will be importing the package and a real PKC file, input the data, getting the prediction. So in 4.5 will be telling steps to execute, run, implement on the project. This is the input of our program. So here we'll be giving wind speed, wind direction, temperature, and pressure. These four as input. We'll be entering the wind number according to the wind speed, wind direction, temperature, and pressure. We'll be getting the output. See, in output design, we have design time series plot, error analysis, scatter plot, performance metrics.
The next one is testing. Types of testing. Here we have tested our code with three types of testing: unit testing, integration testing, and system testing. First, here comes unit testing. In unit testing, we have been checked and tested each individual unit of the system. And then in integration testing, we have been tested the integration between the system components with the user, deployment user. Next, system test. System testing is a type of software. Like here in the win prediction of regression, the system would involve in testing of the entire system. So the system is being tested. Here it is the test image. We can see here the red color mark is the predictor power, and blue one is the true color. Here, here we can able to see a very light, minute changes, and here I'm here to say that we are having a 99% of accuracy level in predicting the win. Next, result and discussion. In result and discussion, first subtopic is efficiency of proposed system. In efficiency of proposed system, wind power prediction using decision tree is a method. To improve the efficiency of the proposed system, it is important to optimize the decision tree model by tuning the hyperparameters such as maximum depth of the tree, minimum number of samples required to split the nodes, and then criteria used measuring the quality of the splits. Additionally, a feature selection technique of a correlation analysis, principal component analysis, which is PCA, and recursive feature elimination can be used to select the most relevant feature of wind power prediction. Overall, the efficiency of the proposed system is a decision tree regression method can improve by optimizing the decision tree model, pre-processing the data, selecting the relevant feature for prediction. The project have achieved the best result using decision tree with 99.9% of accuracy in predicting the wind power values. These are the sample codes like which we have used a decision tree algorithm. Here we can see the output. First one is the code output of the decision tree, where we can see the accuracy level, it's 99.9 percentage. And then down is the front end output, where we can able to give the input for by the user, and we can predict the output of the load which is being predicted. This is the outputs. Next is conclusion and future enhancement. Conclusion. Our study have presented the feasibility, benefits, and everything, algorithms, as well as the technical and social challenges, the data flow diagram, everything. Overall, the implementation of the regression-based wind power prediction system can lead to cost saving, increased efficiency, and more reliable and sustainable wind power production. The project have achieved the best result using a decision tree with 99.9% of accuracy in predicting the wind power values. The future enhancement is to we can able to develop an AI model. The real-time data to improve the prediction accuracy, expanding the data input and include the more environmental factor and social data. Additionally, a system could able to scaled up accommodate a large number of wind turbines, wind farms, providing an even greater benefit to the renewable energy resources. With continued research and development, the future wind energy produced looks bright. And that's it. These are the data codes and everything. Here, Texa turbine. This is the data set which we are going to use as data set. These are the historical data which we have been collected for from the past. And these are the modules, pre-processing modules, data visualization modules, linear regression modules, decision tree modules, SPR, and elastic net. These are the codes which we have been finding the accuracy level. This is the data pre-processing model. By running the data pre-processing, we are just removing the uncertain values. By running this, we are just removing the duplicate values. And next one is data visualization. Here we are just seeing the data in a pictorial graph. We can see the pictorial graph over here, scattered block. And then next is linear regression model. In linear regression model is an algorithm which is we are going to compare. In this, we can able to find the accuracy level is 91.07. And next is decision tree. In decision tree, this is also is going to be compared. And then we can say this is the best model by the accuracy level 99.9 percentage. And third one is an SVR model. In SVR model, by comparing all these, we are saying that C level, the accuracy in this level is just 3.4. And then by compare, and then is last in elastic net. In elastic net, the accuracy level is 91.9, 91.13 EMD. By giving the location command, we are going to run Python space manage.py space run server. By running this location, we can able to get an link, an URL. By getting the link that we are just used in an URL Chrome, we can able to get this user interface of the project. Here we can able to see the wind speed, which here we are going to enter the wind speed, pressure, wind direction, air temperature. Now we'll just check out the prediction. Now we have entered this columns data here. Now we will just predict it out. You can see 1422.61 kilowatts. 1422. It's like 1433. It's like only little minute variance. So it's like we are saying that decision tree is just giving out the 99 percentage accuracy level in predicting the wind power. Thank you.
Coming to the introduction, here we are going to derive about our project which we are going to do. So here we are going to provide privilegization shift of electrical generation towards clean. And here will be a supplying industry has undergone numerology, structural and semantic change over the past several years throughout the world. And here now, as we are introducing a new system, and now here if we tell about in existing system, it won't be giving the accurate value and we need lot of process when we are doing. Now we are going to propose our topic on prediction wind power generation. Here we'll be giving the maximum accurate value which is going to give 99.9% outcome. So here we are using the Python language, and we are going to develop, we have developed in modules. We have divided into 6 modules, and we have run, and will be showing output in Anaconda. Here we have chosen 4 algorithms, and by comparing all these 4 algorithms, decision tree is the best. So we are going to show it. And in module